Hello, and welcome to the Introduction to the ISN Control System. In 1986, York became a European controls distributor for ITL, an English building automation company. During 1988, York acquired ITL, invested in R&D, and continued to grow sales in Europe. In 1991, York International introduced the ISN Fax 4500 direct digital control system. In 1998, the ISN Millennium Series controllers were introduced and included the EDC, LDC, and FDC controllers. 1999, York International discontinued production of the ISN control system and contracted with Johnson Controls to brand label control systems for York. In 2001, York International decided not to renew the contract with Johnson and restarted production of York ISN controls. In 2002, York introduced the Advantage family of ISN controls, a full line of programmable controllers that provided network communications to all York chillers. Finally, in 2004, York introduces the ISN Connexus family of BACnet-compatible controls. The York ISN control system manages various building systems. It ensures the operational performance of the facility as well as the comfort and safety of building occupants. As an energy management system, it can monitor, measure, and control electrical building loads, like HVAC units and lighting systems across multiple locations. York ISN controllers can be used in a factory-assembled package of sensors, terminal units and heating controls. The ISN control system is used for chiller plant automation, to streamline plant operations and lower operating costs with control of chillers, VFDs, and pumps. The ISN control system provides sophisticated alarm processing and routing. The lighting control functions of the ISN Connexus control system is used to control both indoor and outdoor lighting of commercial, industrial, and residential spaces. The ASHRAE BACnet protocol provides communication between the York ISN Connexus control system and other manufacturers of BACnet-compliant building automation devices. The ISN Connexus control system utilizes the ASHRAE BACnet protocol, which provides interoperability with third-party BACnet devices. The CXI-DC controller is designed for mid-size applications and has a total of 19 I/O points. 4 universal inputs, 7 thermistor inputs, and 8 universal outputs. A battery-backed real-time date clock. Non-volatile flash memory for backup of all application data. An RS-232 serial port for connection of a PC or terminal for programming and monitoring. The RS-485 network port is used to connect to other ISN controllers. And an optional keypad display port. The UDC is a general-purpose modular controller designed for larger applications. It has an I/O capability of 11 to 110 I/O points using input and output expansion modules. There is a battery-backed real-time date clock, and a non-volatile flash memory for backup of all application data. An RS-232 serial port for connection of a PC or terminal for programming and monitoring. The RS-485 network port is used to connect to other ISN controllers. And an optional keypad display port. The UDC optional enclosure is designed to contain the controller, multiple I/O modules and the keypad display module. The keypad display module is designed for monitoring and editing, accessing reports, acknowledging alarms, and also as a service tool. The TDC is a small self-contained custom application controller. The TDC-8E has 2 universal inputs, 2 thermistor inputs, 3 analog outputs, and 1 digital output. The TDC-9E has 2 universal inputs, 2 thermistor inputs, and 4 digital TRIAC outputs. The CXVAV controller has 11 I/O points, 4 analog inputs, 1 universal input, 2 digital actuator outputs, 1 digital output, and 3 digital outputs for heat fan stages. Non-volatile flash memory for backup of all application data. The RS-485 network port is used to connect to other ISN controllers. The CX router interfaces with the RS-485 network and the Ethernet IP network. It resends messages to devices on other connected networks. The CX repeater is used to amplify and extend the RS-485 signal. Up to 3 repeaters can be used to extend the network up to 12,000 feet. This is a diagram of the architecture of the ISN ConnectSys control system network. In red is the ISN RS-485 network of controllers and other devices. On the left side of the chart are the CX routers which connect the RS-485 networks with the facility's Ethernet networks shown in blue. Thank you for watching. If you have an ISN control system and need help, we can provide you with the training, documentation and support you need at reasonable prices, including training tutorials, online training sessions, and on-site training classes. Contact us at cdawson@comcast.net.